So how's it going, guys? So I want to take you guys along on a project I just completed for a customer of mine. I'm going to be dropping it off to him tomorrow. And he's building the piece of equipment. He just gave me the details on a sketch of what he wanted. He wanted 2 limit switches that, as a pipe that is connected to this chain rotates around, is going to trip one limit switch and then change directions of the motor, trip another limit switch, change direction of the motor, trip another. Anyway, so they'll just keep on going on until they want to stop it. So after consulting the customer, we decided on, for one, emergency stop to shut the power down if something goes bad, as well as these start-stop push buttons and the power indicating light. So what these will do now is when the customer wants to start it, they can either push either one of the buttons for either direction. They can stop mid-stroke, whatever. Emergency stop button shuts the power off to everything. This will be ran by a standard 120 volt 15 amp receptacle. And the cool thing about this, I haven't played too much with this kind of stuff. This is a 90 volt DC motor. And if we open this up here, in here, so now if we open it up here, in here, we have a DC motor controller, forward reversing speed controller for this DC motor. Now, in my world, I haven't played too much with that. I've played with a lot of variable frequency drives for bigger AC motors, but nothing on the DC world. So this was pretty neat playing with this. But inside we got all the push buttons wired up. We got the latching relays hooked up, and those trigger these 2 spots right here to go forward and reverse. So let's plug this in and show you guys what exactly this does. So to operate this, pretty simple and straightforward. We pull out the mushroom button or the e-stop emergency button. We then have a power indicating light to tell us that this is now live. So we can hit either one of the buttons for up, stop, down. We can also finally adjust the speed to a stop. And then with these limit switches, once his piece of equipment's all set up, he'll trip one limit switch and then trip the other limit switch to change directions. So yeah, let's take you guys on a closer look to how the wiring diagram looks for a piece of equipment like this. It's pretty simple, looks complicated, but it's pretty simple. So when I build these, I always draw out everything, but I draw it out. I know a lot of guys use probably a computer program to use to put a line diagram like this together. I don't know how to use those. I don't know of one. So I just scribble them out by hand. This took 3 drawings to make up. First one you do like a scribble sketch, make it better, and then you do it until you have one that you're going to use. Like this was the one I actually used to build it. You scribble in all your notes and you just go from there. Once you have all your corrections made, I make a proper one. It labels the points on the terminals that I use. So any of the push buttons, any of the contacts, all the nodes on any piece of hardware has a numeric value to that terminal. So I always write that down. Then what I do is I start from the beginning and I just label the wires. I label it, circle it. You can do however you want, underline it. Some people use different colors. Personally, I'm the colorblind electrician, so that's kind of useless for me. That's more frustrating. So I just prefer numbers. And I start from one side and work all my way to the other side. The numbering system is, when you have it laid out like this, everything, it just makes life easier for the troubleshooting. Later on, there was a couple issues that I had when I laid it out. I read the schematic wrong on the contactors or the relays, and I misplaced 2 wires. So I had to go through and figure out why my latching relays were not latching. Because I laid it all out like this, it took me maybe 2 minutes to find the issue and rectify the issue. While building this, I got called out on a couple service calls, had to leave it right when I was in the middle of something, and then you come back to it. Well, I forgot to add in one of the wires to continue on with one of the circuits, and again, it was very easy to go back and see where I'd missed. So I start right from the 120 side, so there's my power in. It first goes to our e-stop. So our e-stop is the whole crap emergency it button. From that e-stop, we go to the driver with a number 2 wire. Size number 2, this is a just numeric value numbered that wire number 2. From there we go to our push button, our stop push button, and then our stop push button, we end up paralleling all of these. So this is our up push button, our up holding contact. So our up holding contact is on that relay right there. So you use a set of contacts on this. So once that's energized, it holds that closed, so this circuit is then constantly energized. This is our limit switch. So our limit switch, when it gets triggered, it does the exact same thing as just pressing the push button. With this up push button, there's also a set of normally closed contacts in there that are now mechanically interlocked with this circuit right here. So when we push this one down to close this circuit to energize up our set of contacts to spin the motor one way, it then opens that set of contacts. So at no point can we energize up and down at the same time. So we press this, it opens up this circuit. So if this circuit is energized, it immediately de-energizes this circuit and energizes this circuit. This is built the exact same way with our down push button, our down latching contact, our down limit switch. And now here we got our down push button mechanical interlock. So when this is pressed, this opens up and it de-energizes this circuit. So at no point in time when this one's getting energized can this one be energized. Now these relays tied into the S1, S2, S3 of this board, and 2 is our common, and when S1 gets energized, it's moving in the up position. S3 gets energized, it's moving in the down position. I wrote this here just for later on if myself or somebody else is trying to troubleshoot it. It just correlates the color of the wire to the number of the terminal in the limit switch, just so it makes it easier for whoever's troubleshooting it down the road. Anyways, hope you guys enjoyed this project, following along with it. If you did, leave a comment, ask questions. If you want more of it, some ideas on what you guys might like to see, and see you guys later.